Okay, cool.
Good afternoon, everybody. What a fascinating story we just heard. World's largest AI infrastructure being run on open networking and SONiC. Remember, until a few years back, we were being told that the only way to build AI infrastructure was to build these vertically integrated solutions and use these proprietary networking technologies. And yet, here we are. Contrast could not be more striking. And I think it's a victory of the whole community's vision, the vision of open networking, the vision of disaggregation, the vision of no vendor lock-in. I think it was a very inspiring story. And on behalf of the whole European SONiC community, let me pay my thanks and gratitude to Gohan and Mehak for coming here all the way from US to tell us this story. I think they deserve a round of applause.
No.
Thank you very much. I wanted a gap between my presentation and theirs because they were showing 500,000 GPU deployment. I'm only going to talk about 10,000, so I wanted people to forget it, right?
And that's not GPUs.
And they're not GPUs. So it is not going to be an AI networking story. But if you are interested in AI networking, I would once again recommend you to stay till the end of this workshop, because Gohan, I think this is the last session where he is going to talk about SONiC for scale-up networking. For scale-out, we have already won, right? For scale-out, everybody now agrees that Ethernet is the way to go. But for scale-up networking, that is the next frontier. We strongly believe that Ethernet is the right network for scale-up networks as well. All right, now coming to my today's session. So I'll start with introduction. My name is Kamran Naqvi. I represent Broadcom's core switching group in Europe. And with me,
Yeah, I'm Tobin Hawkshaw. I work for, I'm an architect in the project team for the IT team at Broadcom.
thank you. And today we are going to tell you a story of how Broadcom moved from a three-tiered, very traditional type of network to an open standard-based, open networking-based, SONiC-based network. So I'll start by just introducing what Broadcom is. I'll just tell you the story at a very high level, and then I will leave you in the capable hand of Tobin, who will tell you the full story. But for those who do not know, Broadcom is a major manufacturer of networking solutions, specifically semiconductors and infrastructure software. We are absolutely a technology company. Most of our employees, like Tobin, myself, Mehak, we are all engineers. We have over 19,000 patents. We take a lot of pride in our research of innovation and research and development. You can see the numbers on the slide. Every year, we spend a significant share of our revenue in research and development to continue this pace of innovation. That's who we are. That's Broadcom. And you can see we have 24 different divisions within Broadcom, so we are quite a diverse company. The story we are going to tell you today, it has some elements of our own products. So the switches that we deployed, they use Broadcom silicon. But my division, core switching group, is just one of the divisions out of the 24 divisions we have. The point I'm trying to make is that we did not, embark on this journey of open networking just to tell you a Broadcom on Broadcom story. We embarked on this journey because we absolutely believe in disaggregation, and our vision aligns with the vision of SONiC community. So as I said, we started this journey in 2019, but before 2019, we had a traditional three-tiered network. I'm specifically talking about data centers, so think about access, aggregation, and core. A lot of spanning tree, right? A lot of VLANs extension, right? And the example we're showing here is for one of our data centers. The top one there, it's from Vegas data center, right? 600 racks and 2 L3 gateways. So the picture I'm trying to paint is when we started this journey, it was a very, I would say, complicated type of network, a lot of organic growth. So much so that, people were scared of going and making a change there, right? Because nobody knew what would happen. And we were using products from a very famous OEM who have a lot of features in their products, but at the same time, a lot of bugs as well, right? So we were all very afraid to make change. But in 2019, we said, enough is enough, right? We are going to make a change. We sat together with Tobin and the team, and the vision that we received from Broadcom IT, that these are the 6 key architectural requirements that we have to include in the next network. And if you look at these requirements, I'm not going to read all of them, you will see that many of them will resonate with you, right? We talk about scale, we talk about a robust network. Cost was important, vendor lock-in. We did not want any vendor lock-in. That was a very, very important factor, right? Security, multi-tenancy, as I said, 24 different divisions doing a lot of different things. So definitely multi-tenancy was very, very important for Broadcom IT network. Of course, we wanted very good performance, and automation was also a key requirement. So when you look at all these requirements, there is only one NOS that will tick all the boxes, and that is SONiC. And I'm very happy to tell you today that we have completed this journey. We have been able to transform all of Broadcom's data center. Remember, at one point, we were running 16 data centers. We've been able to transfer all the data centers, consolidated those 16 data centers into 7 data centers, which is no small feat. And we are running SONiC everywhere. And not just in the data center, we have extended our SONiC deployment into campus as well, and in our WAN deployment as well. Now, to tell you the rest of the story, I'll hand over to Tobin.
Thank you. So yeah, as Kamran says, we were running 2 L3 cores in our largest data center with 600 racks, and everyone was, including me, very scared to do any changes on there. You trip up HSRP or VRRP, and the DC can go down, and then you've got a bunch of people complaining. It was pretty scary, for want of a better phrase. Now we've deployed SONiC in this data center, so we've gone from 600 racks to 1,400 racks. We're running it's getting close to 5,000 switches just in that single data center alone. Things are much better because we're using a decentralized setup with VXLAN. There's there's less single points of failure, so people aren't scared to make changes. In fact, we pretty much do an upgrade at least once or twice a year to the entire DC with zero downtime, which was unheard of when we were looking at 600 racks in the early setup. Also, as Kamran mentioned, security is a big thing for us. So we didn't have VRFs before. So we've now included a VXLAN fabric with VRFs. That's important because Broadcom owns a lot of other companies, including Symmetric. And those guys can get up to some pretty mischievous stuff in some of their labs. They have sort of what we would call a red lab, where they're detonating malware and doing all sorts of things. We don't want that anywhere near the corporate traffic. So this is the initial architecture that we started with. We're showing very small 2 pods here, and it's a symmetric VXLAN setup. We do no VRF leaking, so there's actually a firewall in the middle here, and we will basically route between all of the VRFs with the firewall injecting a default route into every VRF, and that's how we're doing it. The reason we do that is simplicity. One thing we found is the architecture can be great, but it's not designed, it's got to be simple for operations to be able to take it over. We run very lean, and so creating a bespoke special network for every engineering team would be great in the short term, but a long-term arc would be pretty bad. So we keep everything pretty simple, no VRF leaking, even that. So what we're showing here is 2 pods. This is probably the diagram for our original largest data center. That's now running 70 pods. So each of those pods is basically running 20 racks. There'll be 4 spines per pod, 400 gig uplinks per TOR. So we've basically got 400 gig east to west. At the moment, we're looking at 1.6 in the future, but yeah, that's happening at the moment. We have SONiC installed on every one of those switches, running Symmetric VXLAN. We also have a sort of hub and spoke type architecture here, where pod 0 is the sort of pseudopod in the middle that connects all the other pods. We're also running not quite 514 BGP sessions or 512, but we do run multi-site between at least, I think, 126 pods, and then the rest of the pods all run multi-site. So these border leaves will basically create an external tunnel between each other. And so there are a lot of BGP connections, and you can imagine a massive routes, because all of the /32s or the host routes are being shared between those border leaves. So those border leaves really have to work. They're currently running Trident 4s, but yeah, they get a lot of routes from the system. So after we successfully, so as Kamran mentioned, in 2019, we deployed it in Reno. That was our first data center. Subsequently, that data center's gone now. We generally blow up to a more larger data center size when we make an acquisition. And then, unlike a lot of companies, we generally standardize everything. So any company we purchase will then be running Broadcom standards within a year, 2 years max. And so we generally consolidate those data centers. So we're back to running 7, briefly 16 after the VMware acquisition. And it's running pretty well. Since 2019, we haven't had any large issues. I mean, when we initially adopted SONiC, it wasn't able to do Symmetric VXLAN, so we had to wait for that to come in. So we did actually run it, talking about getting rid of spanning tree. We ran it initially with the spine and leaf cabling architecture, but with spanning tree. So the border leaves became, if I snap back quickly, the border leaves basically became the cores. And then we were running spanning tree everywhere. And then when Symmetric VXLAN came in, we then deployed that pretty quickly. So we were there pretty early on. After the success, Kamran mentioned vendor lock-in. It's been a lot cheaper. We don't have a lot of outgoings paying for huge amounts or millions of dollars for support every year. That's all gone. And it ran pretty successfully. And so after that, we decided, okay, where else can we do this? And the most obvious point was the WAN routers. So we don't run MPLS protocol ourselves. We were running layer 3 MPLS handoff from carriers at that point. And so it's very easy for us to be able to, because we're just BGP peering, get rid of all the WAN routers in the data centers. We did that. It ran pretty successfully. So we decided, okay, let's change all the switches that we've got in the WAN stack with SONiC also. So we continued to do that. That ran pretty successfully. We also went out to, we've got about 93 sites, that fluctuates, but those all had 2 routers, a primary and secondary. We went out and changed all of those as well. So and we moved pretty fast at Broadcom. So this all happened probably, the WAN rollout probably within a year easily, maybe 3 quarters, something like that. We moved certainly at a pace. And even that was successful. We've subsequently, in the campus side, we've got rid of the routers now because we briefly owned an SD-WAN company and we actually adopted their technology, so we're still running Velo in the setups. But yeah, so we went down from the WAN in the campus. We've replaced the campus cores. That's an ongoing project at the moment. So we've literally got thousands and thousands of these switches, like the initial title of the thing. It's about 10K now. We're certainly getting close to it. And we're still going. So there's new pods in the data centers, new campus sites, and this is pretty much our standard. So any site that hasn't been rolled over to SONiC, any new site we stand up, that's the first thing that goes in. The whole network has to run SONiC. We run the same version everywhere as well. What else have we got? Lab cores. So we also have these sort of mini networks. We have labs in the data center, but as mentioned, there's a lot of BUs with engineering labs. And we have a lot of high-touch labs. And basically the difference between a high-touch and a low-touch is low-touch is in the data center. It means somebody's not plugging in a dongle or they don't have to be hands-on with their lab equipment. A high-touch lab is generally set up in the campus itself. We basically put a firewall in there and split it off. Those can get to quite a size. We've got some of those with, there's certainly one with 1,000, 1,500 switches in it. Those are all being swapped for SONiC as well. So yeah, we're swapping everything. There's some ongoing campus setup. So there's a few sites, I think it's probably about 15, where they're rolling back and getting those swapped out. We couldn't do it on the first site, first sweep due to timing. But I think these settings are probably wrong. I put these on here, but I think it's slightly more. So I think there's probably nearly 900 to 1K switches in the campus. And because of the large lab, that it sort of skews that number probably up to about 600. So learnings. So things we've come across on the way of deploying SONiC. I probably actually mentioned a few of these. The first one is we needed Symmetric VXLAN. I didn't want to mess around with configuring VLANs on every switch in a pod. So Symmetric VLAN was one of the things that we waited for. That's now deployed everywhere. We've got how to handle firewalling and security. So that it's working. I still don't like the fact that everything's centralized through a firewall. I mean, it would be perfect if it was a decentralized setup in the switches themselves, but at the moment, we've solved that by putting in pretty hefty firewalls to do the inter-VRF, inter-pod communication. And we also basically have separate mini DCs going in sometimes, and those will span off of pod 0. So pod 0 is really the hub. And those will have firewalls. You get into a small issue there where if you have two sets of firewalls, now you need to work out, okay, am I going to run into asymmetric routing because one side's using one set of firewalls to do into VRF and the other side's doing the other. So that became a problem. That's now solved, but I still think there's a better way to do it somewhere. Early versions of SONiC brought bugs. As I mentioned, we were in very early. I can't remember, it's 2 point something that we got in. A lot of the systems were running 3 for a very long time until we got 4, where we moved from click to clish. Now everything is running clish. Automation was a big thing. Obviously, if anybody's rolled out or changed the operating system, a lot of network engineering is rooted. They have biases and favorites, whether it's because they're certified with one set. They don't like to change. So initially, there's always there's a bit of inertia there, but once they get used to it, it's pretty good. Everybody's happy with it now. The education of new tool sets. So we went from manually configuring everything via CLI to automating it over CLI. Then we went to Ansible to stand up and bring up the DC. I think Ansible's great, but it's like borderline automation for me. It's more of a sort of macro setup. And then we're now using an orchestrator created by Pantheon there, which we created with them for the DCs. Hardware vendor help with tuning files. Sorry, I just had to slightly remind myself what that one was. I think we had one of the things going from a typical vendor to a sort of the white box, grey box setup is you're allowed to use any optic. Now you're allowed to shop around, which is huge because I was having a discussion a couple of days ago with someone about how expensive a certain brand of optics were, and it's absolutely ridiculous. It's crazy. So we're allowed to go out to cheaper vendors that can do next day delivery and get those shipped over. There was a couple of issues where they had to do tuning files in order to get the tolerances correct on files. That was very early on the switches, sorry, I should say. We haven't had many issues like that, but that was a very early issue. Okay, so where next? So we're currently looking at what else we can deploy. Obviously, I'm saying it's a success in the data center, it's a success in the campus and in the labs. So where can we improve it? So when the new technology comes in, we can then, I should say, we've had it long enough now to see its pain points and where we want to improve it. One of those pain points is in the DMZ and just the general use of NC lag. Any issues that we've had on a lot of networks where we've said, oh yeah, there'll only be 2, 30-minute blips and everything will be fine. And then sometimes it's a bit longer and people start shouting, have generally been with spanning tree and MC lag issues. One of the biggest issues is engineers will come in and expect the network to be perfect before they start their work. So they'll say, move this link, move that link, let's do this, let's do that, it'll be 30 minutes outage. But what they don't expect is there is bad or misconfigurations in there hiding, waiting for them. So it's like a bear trap, basically. So as soon as they start tugging on cables and moving stuff around, you generally get a larger outage. Those, as I mentioned, have mainly been MC lag and spanning tree. So the idea that I'd like to test in the DMZ, and this is an initial design, we haven't deployed this yet, is to replace MCLAG with ESI, and we'll basically put VXLAN into the DMZ itself. The testing of ESI seems to work pretty well. We've done some testing with the help of CSG. It looks good. I wish there was an MCLAG separate IP though in there, just if you're listening for a future feature request. But apart from that, it's running pretty good. So we're going to deploy this, and then once that's there, I'd like to move the ESI into the data center itself and get rid of MCLAG completely. But that's where we're in now. I also mentioned briefly NSX. So you can imagine, since buying VMware, we've got a whole lot of NSX instances that have sprung up. In order to peer with those T0s, previously, because it was a layer 2 network in the DMZ, we had to do that to the firewall. This will allow us to actually peer to the access layer, which is what we do in the fabric. And then we'll have a lot more NSX running with their DFW and et cetera in the DMZ. So yeah, this is just another diagram of the DMZ. This is only one half, obviously. Internal. We have an internal and an external DMZ, but it's basically flipped around the firewalls shown at above. And that's pretty much it. The only thing that concerns me slightly about this architecture is the amount of route reflecting. And there's routes pinging around like ping balls in there, but so far it's working. If I can resolve that by the time we deploy, I will. And that's pretty much it. Any questions at all? Yeah. Yeah, do you want this? No. We can go back and forth. No, thank you, Kamran. Yeah.
You mentioned swap outs.
Yeah.
Is that mean physical? Is that you talking about ASICs, or is it just software?
Physical. So you mean the outages in the
To go to SONiC.
Oh yeah. Yeah, we were using a different vendor that Kamran mentioned we were locked in. So those were completely swapped out. I did also mention the upgrades. So we're swapping one version for another. We're doing that without any hardware swaps at all. It's just, it's seamless. And that is a sort of we call it a no outage. Basically, it is a small blip, but that's working pretty well.
So it depends if you might have to do a physical, you might have to do a...
So we had to do physical. Now we're done with the physical. There's a couple of campuses left that I think are still running some old vendor switches that we're going around and sort of hoovering up. But yeah, all of the hardware itself is done. So we're running pretty much, we're always looking for new SONiC vendors, hardware vendors, but yeah, we're running entirely, certainly in the data centers, or SONiC switches. Yeah.
Your time is not supposed to be sorry.
Thank you, gentlemen. Before you run away, we have also something just to memorize, yeah?
Ah, perfect.
Really
Thank you. Right, it's off.
You are already collecting that, yeah? It will be your...
You're going to get a few. 6.
Yeah.
Thank you very much.
Thank you.
Thank you.